Hello, and welcome to the first part of the zombie tutorial. This is a part 1 of a series where I go over all the components that Unity provides that we can use to make a super simple third-person shooter. It will contain zombie AI, weapon spray, and grenades. It may not look the prettiest by the end, but it will be functional, and it'll show you a lot of the cool fundamental components of Unity. We're going to set up the controls and the camera in this one, so feel free to use this tutorial as simply a third-person game setup. That being said, let's jump right in. Okay, first things first, we're going to set up our play area. And so I'm going to go ahead and add a plane so we have something nice to walk on. And I'm also going to scale it up by 5 units to make sure we have a nice wide open space to play in. From there, we can add what will be our player component, a 3D capsule, and then we're just going to adjust some of the position values to make sure that it's nice and level with the floor. If we highlight the player object in the hierarchy, on the right in our inspector tab, we can click the add component button to add a rigid body component. Let's create a script called player, click on the 3 dots to the right of it and edit script. Alright, so we're in the coding section now. And so first things first, we're going to need to use that rigid body we just added to really apply those forces. And so best way to do it is just create a reference to that rigid body. Here on line 8 is where we actually declare the rigid body name, but then in line 13, we can use get component to like gain access to it. It's kind of weird. The first line is really just saying that we're going to need one, but then that second line where it says get component, that's where we actually grab it. And so we're going to use fixed update for this one. Fixed update is good for all physics updates or like physics functions and things like that. And so we're just definitely going to need to be applying forces in the fixed update function. One thing to know about adding a force as well is we're going to need to apply a force in the direction that the player wants to move in. And so we're also going to need user input for this one. I mean, that's duh, right? It's a video game, we're going to need input from the player. But just got to understand that when a player is pressing forward on the joystick, that equals a forward direction to the player. And so now we got a nice template going on here. We have a move function that we pass in a direction, and so that's going to be the player direction, like I mentioned. We're going to call it every fixed update, so that's good. But now we're actually going to need to take that player input and transform it into a direction. And so how do we do that? We're going to actually need a package called input system. That's one of like Unity's built-in packages. So we open up package manager, go to Unity registry and scroll down until you see input system. Go ahead and click install, and at this point Unity will either prompt you to restart the engine or you'll just have to close Unity out and then start it up again. Navigate to packages, input system, and then plugins so we can take a look at the actual mapping of our input. We're going to be using the player action map, specifically the move action, to take input from both keyboard or gamepad. And one thing to note is that it's a vector 2. When you're holding up on the controller, like on the joystick, your Y value will be 1. And if you're holding back on the control stick, the Y value will be -1. Same thing for the left and right. If you're holding right on the controller, your X will be 1. And if you're holding left, your X will be -1. Got it. Okay, added some lines of code here. Added the using Unity Engine.input system on line 4 to gain access to the default input action class, and declared the action map under the rigid body. And that first line only allocates memory for the action map, but to actually fill that memory, we have to set it equal to a new default input action in the awake function. Also adding some more functions down here. It's the on enable and on disable functions. This is just to make sure that the input system gets disabled whenever the script gets disabled. And now since we added a whole bunch of lines of code that we only really need to look at once when we make it, so I'm going to go ahead and put them in a region called initialize input and then just minimize it Just makes it 10 times easier to look at, and it shrinks the screen size down. So that's a plus whenever you're working with a lot of code. And now we're going to need two more variables, a vector3 to store our player direction, and a vector2 for the player input. Remember, those are two different things. One is just what the player is pressing on the controller, but the second one is actually going to be used to apply force. And so now we're going to head into the meat of the burger. How do we grab that input? Well, here's the line. If we use input.player.move, we can read the value of the user's input, and it gets read as a vector2. And to convert it into a direction, we just use the x and the y values as x and z values instead in our vector3. I guess you'd think the y value would also coincide as like a y value in the vector3, but in 3D terms, y sends you upwards, so we don't want that. We want x to refer to us going forward and backward, we want x to refer to you going left and right, and we want our y to refer to us going forward and backwards. But z is forward and backwards in 3D, so if the player is holding up on the controller, that refers to up in the 3D world, which is z. Hope that makes sense. Alright, and if we hit play and we start applying those forces, we can see what happens. And it was a complete failure. The video's over. We failed as game developers. It's over. No, okay, so we can open the rigid body on the player component, and then if we just disable rotation in the X, Y, and Z, then we can try again and see what happens. At first glance, it looks like it's not moving, right? But if we look at the transform, we can see our position values are changing ever so slightly. And so what that means is that it's working. We're definitely applying a force, but it's just very tiny. So how do we fix that? Well, let's multiply that value by a speed value. And so we're going to create a float, call it speed, and then I think a nice base value to start off with was, what, 15? Yeah. We can open up Unity once more, and bada bing, bada boom, it's working. She's moving. We are now in the camera portion of the tutorial, and so once more, we're going to go ahead and go to Windows, Package Manager, Unity Registry, and we're going to look for Cinemachine. This is a great package that contains a bunch of camera utilities, and specifically it's got a great one for third-person shooters and just third-person camera movement in general, and that's what we're going to go for. Okay, in case you missed it, we went ahead and added a component to our main camera called Cinemachine Brain, and now we're going to create a new game object that's going to hold our actual camera. So, two different things. And add a Cinemachine free look camera to our third-person camera object. Okay, a few more things we got to do before this camera is up and running is we're going to go ahead and drag our player object onto the follow and look at spots here on the Cinemachine free look component. And then just also make sure to click that add input provider if you're using the input system that we just imported, which you should be if you're following this tutorial. And but lastly, I'm just going to go ahead and put up a screenshot of all the values that I've been using on my camera component. And it's just a little bit easier than running through and kind of giving a rundown of each decision. You can just take a look and just copy it yourself, or feel free to play with the values however you want, but I found that this one works pretty well. So things to note on this one in terms of differences are the orbits, specifically the binding mode. I switched that one to lock to target on assign. I lowered the spline curvature down to 0, and then the top rig, middle rig, and bottom rig all have a radius of 10. I feel like that pushes the camera away enough that it really does kind of feel like a third-person perspective, and you just get a lot more field of view. And then also make sure to lower the damping on all these values here on the body to 0. So click through on the top rig, middle rig, and bottom rig. You'll notice that each one has a different damping setting, or they have their own individual damping settings. Make sure they're all 0. Unless you like that kind of delay on the camera when it follows you, then feel free to raise them, but I feel like you get more snappy, more control when they're all 0. Okay, so you probably noticed some of the colors changing. It was hard to see the capsule on the plane, so I went ahead and made a folder called materials, and then I just created a new material. I think I created 2. One is brown for the ground, one is red for the player. So, adding some color. Okay, as we move into our final step here in this tutorial, I just wanted to point out that this camera movement so far does not take into account camera rotation. So every single time you hold forward on the controller, you're going to go straight relative to the world space. But if you turn the camera to the right and now you're facing, say, east, and you start holding forward, you're still going to be heading north. Whereas if you're facing east and you're holding forward on east, you're going to want to go east. So that's what this last chunk is going to be about. Okay, from there, to gain access to the camera's rotation, we can refer to its transform by calling towards camera.main.transform. From there, we got to extract that Y component of its rotation, since this one controls in which direction the camera is facing, but only left and right, so not up and down. We don't care if it's looking at the sky or the ground, we just want to know if it's looking north, east, west, blah, blah, blah. From there, we multiply the direction by the quaternion that we just created, and yeah, we're done. I know it took a bit of a leap in logic there, but just know that multiplying a vector 3 by a quaternion rotates the vector 3. Alright, thanks so much for watching all that. I know it was kind of a lot. You'd think it'd be simpler, and in a way, it probably is a little simpler, but you know, when you got to break down every little part about setting this thing up, it does seem like a lot. But yeah, I'm just going through and cleaning up some of the comments I made on this project. This project is going to be available on my Git for download if you want to, open up this project and play with it yourself. But besides that, I think that's it. I think we can call this a video. Part 2 is going to be coming up soon. I think we're going to be going over AI in that one, as well as some other packages that I think are going to be nice for creating a level. And so, yeah, that's it. Follow and like for more, and thank you for watching.